Is this thing on? Okay. So, hi, welcome back. Because now, guys, we are coming at the end, rapid end of Chapter 1. This is Chapter 1C, Chemistry in Action. We talked about the history, we talked about what chemistry is, what are the limitations on chemistry, why is chemistry so important. But now we got to start looking at chemistry in action. So some very important things. So how do we answer scientific questions? First we start with observation. Okay? Observation, what do we see? For example, okay, what did you observe? I disappeared off screen for a few seconds. You may or may not have seen me drink water, and then I stuck my tongue out and I made some weird sound. That's an observation, okay? Now with that, guys, when we start with observation, there's also data. What is data? That's information, okay? Quantitative data, that's numbers. Quantitative data, that's numbers, like 5 grams, 20 seconds, 3 bubbles formed. Those are all quantitative data. And for a number of our chemistry experiments we're going to do this year, it's going to be quantitative data. Now there is also qualitative data. Qualitative data, that's description. Okay? So example, water turned green, gray smoke from reaction. So it's a description, okay? We gave the little kid a lot of sugar in his Kool-Aid, and in 5 minutes the kid is running around the room totally active with a lot of energy. That is a qualitative data, okay? Quantitative data, we have the kid say the alphabet, A, B, C, D, E, F, G, as many times as he can in 1 minute. Okay, he did it about 3 times in 1 minute. That is quantitative data. It's a number. 3 times he said the alphabet in 1 minute. Okay, moving on. Now, again, we start with observation. And that's what we got something called deductive reasoning. General to specific. And that's typically what we use. Example, any material floating on top of water is less dense than water. Motor oil floats on top of water. Therefore, motor oil is less dense than water. That's a deductive reasoning. We start with the general statement. Any material floating on top of water is less dense than water. Well, that would make sense, because if it's more dense, then it would sink, right? Now, motor oil floats on top of water. Okay, so we know motor oil will float on top of the water. Therefore, motor oil is less dense than water. We made ourselves a conclusion by deductive reasoning. Okay, there is inductive reasoning. Again, inductive reasoning, known data to unknown general conclusion. Known data to unknown general conclusion. If, then. And that's a lot easier to explain, an if-then statement. Example, sodium chloride, potassium chloride dissolve in water. Therefore, barium chloride should also dissolve in water. Dissolve, breaking into pieces. Okay? So that's an inductive reasoning. If this is true, that sodium chloride, potassium chloride dissolve in water, then barium chloride should also dissolve in water. We would expect that. So that's inductive reasoning compared to deductive reasoning, going from general to specific. Here, we're taking known data and making an unknown general conclusion with it. Okay. Now we switch to the scientific method presentation. Really fast here. Overview of the scientific method. Think about observation, question, hypothesis, experiment, data collection, conclusion, and retest. Okay? Observation. What do you see happening? Example, you see condensation all around the outside of the glass. Okay? Example 2, you notice mold growing on the bread. In other words, think about observation. It's our problem. Here's our problem that we need to solve. What's going on? Why do we have condensation all around the outside of the glass? Why is it that we have mold growing on the bread? This is what we're seeing. So the question is, how does the air temperature affect the condensation formation? Here, does temperature affect how much mold grows on the bread? Okay, so we're still two separate experiments here. So a hypothesis, what is it? A hypothesis, it's a suggested solution to the problem. This is something that we're trying to test. We may or may not be right, but that's something we need to do. It needs to be testable. Okay? Not detestable, testable. If you can't test it, it's not going to do you any good. You can come up with all kinds of ideas, but it has to be something you can test to see, is this true? Now, sometimes it's written if-then statements. The idea is, with a hypothesis, it predicts an outcome. Okay? It predicts. It says something about the future. We would expect something to happen. That may or may not happen. That is part of the science process. So for us, for our hypothesis, if the air temperature is 25 Celsius or below, more condensation will form than if the temperature is greater than 25 Celsius. For our experiment with the bread, if the air temperature is 25 Celsius or below, more mold will be present than if the temperature is greater than 25 Celsius. So we have two hypotheses, one for the water here on the glass, and then one for the mold on the bread. And that's both based on temperature. So now we have to look at variables. We saw our problem. We came up with a hypothesis to explain what we're seeing. What are the variables? Now, these are factors that can be controlled, changed, or measured in an experiment. So, any factor that can be controlled. Well, what do we mean by factor? It's something that we can control it, we can change it, we can measure it in the experiment. That would be a variable. Okay? In algebra, they talk about x being the variable, right? Or y being a variable. You know, 2x plus 4y equals 487. What's x and what's the value of x and y? That's what they're looking at. So, types of variables, there are dependent variables, independent variables, and controlled variables. So a dependent variable is the variable that you measure or observe. That's pretty much it. The dependent variable is the variable that you measure or observe. Okay? 1, how much condensation is measured? That's our dependent variable for our water on the glass. For 2, how much surface area of the bread is covered by the mold? That's our dependent variable. This is what we're measuring. This is what we're seeing. This is what we observe. This is what we measure. Okay? That's our dependent variable. The independent variable is one condition you can change in the experiment. We can change the temperature to 45 Celsius, which is above the 25 Celsius range with this. That's our independent variable. We can change that. Now, we can change the temperature here in our bread to 15 Celsius, which is in the below 25 Celsius range. Okay? There is also the controlled or variable, or the constant variable. That's a controlled variable or constant variable is a variable that does not change during an experiment. It doesn't, we don't do anything with it. So the experimenter makes a special effort to keep other factors constant so that they will not affect the outcome. Okay? So in other words, we want to make sure that those variables, we don't change them at all during the experiment. So, number 1 here, The type of drinking glass that we use in our condensation experiment, it's the same. We don't put anything different. Same thing for experiment 2, the same type of bread. Is it white? Is it wheat throughout the experiment? If we use to test the mold, well, we'll use a loaf of white bread and a loaf of wheat bread. No. That won't work. Because you could make the argument, well, the white bread is better for growing mold than the wheat. No, you either do all wheat or all white, or you go home. That's it. That's pretty much it for that. Control. What's the purpose of the control? Controls are not the things being tested. We only use them for comparison. That's it. Okay? Well, what do you mean? In other words, for control, let's say you're testing a new type of medication. You have a group of people who will test the medication. You have some people who do not get any medication whatsoever, and you got some people who are told they are testing the medication, but in fact they are given fake pills. Okay, so we can control the person with the fake pills. Our dependent variable is the people who are actually trying the medication. The control is the person who's not taking anything. Experiment. So now we're doing data collection. So for our water on the glass, how much condensation is there on the glass based on the temperature? Above 25 Celsius, below 25 Celsius. In our mold on bread, how much surface area of the bread is covered with mold based on the temperature above 25 and below 25 Celsius, depending how you do it. But that would be an example of data. How much area you have. How much condensation do you have on there? Okay. The conclusion, the answer to the hypothesis based on the data obtained from the experiment. Okay? That's a key thing. The answer to the hypothesis based on the data obtained from the experiment itself. We retest the hypothesis. Why? In order to verify, is it true, the results. Experiments must be retested. Scientists do this over and over and over again. They test and they retest, and because there's a lot of things that could happen. Maybe there was an accident. Maybe there was some random thing that nobody knew anything about. So we have to retest it over and over and over again. This is actually one of the reasons why, typically for our labs, we do more than one trial, typically. We don't always have that luxury, however. Surveys, yeah, scientific surveys randomly select representative samples from a larger population. Not going to worry about that too much. Using the results, peer review, that means other scientists check out, seeing what you're doing. Theories, so if hypotheses have some data to back it up, we can talk about theories. And then scientific laws. Now, scientific laws like the law of gravity, that's kind of an obvious one, okay? Now, as we're winding down chapter 1, there's two kinds of applied science. There's applied and pure. Applied science, we're exploring natural products and processes for specific applications. Okay? So, in other words, if we're looking for a new kind of metal to go and put on computer boards to make the electricity travel faster with less resistance in the wire, that would be applied science. Whereas pure science probes nature to learn new things about the universe that we live in. Okay? So an example of that would be looking at the reproductive habits of rattlesnakes out in the desert. Or maybe, I'm just thinking off the top of my head here, if we were trying for studying what are the effects of, you know, the sun's solar cycle on how the planets revolve around the sun. Okay, there's no practical process, there's no application for it. That's just finding out what are we trying to understand in our universe? Okay. And with that, ladies and gentlemen, we are done with chapter 1. Catch you on the flip side.